This is something we're super proud of. And we are a tech consulting company, and we care a lot about sharing knowledge and spreading ideas, having discussions, and just kind of having a discourse with the world and our communities around us. And that's really the goal of our webinars, is to talk with each other and share ideas. So that's what we aim to do today. And with that, Vid, I'm going to hand it right on over to you.
Thank you, Ellen, for this wonderful introduction. All right. So, hello and welcome from my side as well to our webinar about iOS development and which approach to choose for your next awesome mobile application. We're going to go through some of the approaches available. We are going to discuss their pros and their cons, and in the end, we're going to take a look at some of the possible real-life examples. The outcome of this webinar is to give you knowledge and insight to help make better decisions about which tool to use for development based on your requirements and also capabilities. First, about me, a few things. I'm a Swift engineer, and I have more than a decade of experience in building iOS apps. I like to tinker with Swift and explore its potential on various platforms. That can be phones, computers, and lately also cloud or servers. I've mostly been focused on building iOS apps, but I have also worked on multi-platform apps that were running on Windows, Macs, and Linux. And this is where I got the experience of what it's like to build and ship an app that has to support multiple platforms, have the same features, and also do it really well. Okay, let's continue. I'm going to give you a brief introduction of the process of developing an app for iOS. We're going to focus on two main approaches. The first one is called native, and it involves programming languages and development tools provided by Apple. This approach gives you a first-class support for all the features available on Apple's devices. The language of choice here is usually Swift. It's a programming language that was developed by Apple's engineers and later on open sourced. So it's not only running on Apple's platforms, but also, like I said previously, on some servers or other devices. The second method is known as cross-platform. It involves using a cross-platform framework such as React Native, Flutter, or Xamarin to build and run an app that can run on multiple platforms. It can be on iOS, on Android, and sometimes even desktop computers. Although you can use different programming languages here, you still need to use build tools from Apple to actually build and ship your application. This adds a little bit of the complexity to the build process, but once you have it set up, it's pretty much a breeze. The development flow with cross-platform usually means that the developers write common code in a language that is supported by the framework. That can be JavaScript in React Native or Dart in Flutter, for example. The frameworks allow developers to create user interfaces and write logic in a single programming language, and that code is then translated or embedded into the respective platforms where the application will run. As always, there are advantages and disadvantages to both approaches. I cannot offer a definitive answer or guide, and there is no silver bullet when it comes to picking the right approach. But I am going to do my best to present my findings and conclusions that have come through my years of development for the iOS platform. And with this in mind, I'll invite you to move on and take a more in-depth look at the two approaches. So, like I said, the biggest advantage of cross-platform development is the reduced time that it takes to ship the application, especially if you're targeting multiple platforms. An additional bonus is that you only need to develop a feature once, and you can then have it available everywhere. And as well, finding developers that can speak one of the programming languages used by the cross-platform frameworks is usually faster than searching for experienced native developers. But while cross-platform development can save time and resources by allowing developers to build and maintain one code base instead of multiple, it may also have its limitations. For example, cross-platform apps may not always be as responsive and responsive, and snappy as their native counterparts. This usually happens because there is another layer of logic inserted between the source code and the bare metal, and this layer is taking care of translating the instructions into native instructions. And sometimes this translation cannot happen beforehand, but it is actually happening in real time while you are using the application. And if you want access to specific hardware features, many times you will have to go outside of the borders of the cross-platform framework, and you will have to tap into the native development language of a specific platform in order to achieve the desired result. If I can expand on this a little bit, you can imagine you have an application that uses Bluetooth to communicate with certain devices. In order to achieve this using cross-platform frameworks, you will probably need to write some native code in a form of a plugin for your cross-platform framework that will actually do the talking with the Bluetooth hardware on that specific platform. Also, using a cross-platform framework might mean you don't get to use the native user interface components of the system your app is running on. You should especially consider this if you plan on targeting multiple platforms. What looks good on iOS might not work that well on Android, and vice versa. However, this might not necessarily be a shortcoming. In many cases, it could be desirable to have a specific look and feel to the app that is, let's say, highly coupled to the brand of the company. So in that case, you might actually benefit from using a cross-platform framework. But be aware, achieving this consistent look might be a massive undertaking by itself. So don't take that decision quite lightly. Let's switch our attention to native development now. The first hurdle with native development is that you can't always develop and ship apps really quickly. The process is usually more time-consuming than with cross-platform, especially if you're deploying on multiple platforms. You need to have multiple code bases, and you need to watch for feature parity and synchronization of releases between them, to just name a few. Also, finding skilled iOS developers is not always easy, since the entry barrier is a little higher than with, for example, web development. You need to have access to the right hardware, which is not really cheap, and it's not always easy to justify buying that. But going native can give your app a huge performance boost. Using a programming language that is specifically tailored to run on iPhones, of course, will give you an advantage. You are closer to the metal, and that counts in a lot of situations where the responsiveness and speed of the app are important. You also get access to a whole bunch of functionality and features that the iPhones support. It can be access to Bluetooth, dedicated processing units, or even support with technical documentation and sample code. If you go the native route, Apple has got you covered on that. And lastly, by leveraging the native components offered by the SDK, you can be sure that your application will look like it belongs on the user's screen. All of the interactions are going to be smooth, everything will work as expected, and it will give your users that comfy, familiar feeling and might also boost their productivity. Achieving the same consistent look on all platforms might be more time-consuming when using native, since you have to develop the user interface separately for each platform you are targeting. So, choosing between the two options can be difficult. You need to be well aware of your requirements and priorities before you make a decision. Also, different factors may influence your decision, as seen on the previous slide. You can ask yourself the following questions, and the answers might give you more insight which approach would be better suited to you. For example, what sort of developers do we have available? You have to consider their specialization. Also, finding developers familiar with, for example, JavaScript or C# can sometimes be simpler than finding specialized iOS developers. And you need to ask yourself, which platforms are we going to be targeting? And if you're targeting multiple platforms, picking a cross-platform framework might speed up the development time. Well, it's in the name, right? And you will be writing code once and then deploying that to multiple platforms. Then ask yourself, do you need any advanced features or functionality? Maybe you need Bluetooth, maybe you need audio processing capabilities. Taking the native approach might be a better option here, because it's going to give your app an option to interface with those features directly and not through another abstraction layer that might additionally complicate things. Also, is speed and performance an important factor? Again, in this case, being closer to the metal might benefit your applications. And native applications will usually perform more efficiently, consuming less resources, which in turn also means lower battery consumption. And we all know how important that is with mobile applications. And also, what do we want the app to look and feel like? Depending on whether you want the app to feel native to the OS or have an extremely customized interface, in both of those extremes, sometimes it might be beneficial to go with native. On the other hand, if you want to have a custom-looking app and have that same look spread across different platforms, using a cross-platform framework might be better, since you will not need to write separate interfaces for each platform. In summary, choosing between native and cross-platform development depends on various factors, and understanding the advantages and disadvantages of each approach can help you make an informed decision for your project. Now let's move on to some of the examples I mentioned earlier. The first example we're going to discuss is a mobile application for a news website. We want our users to enjoy and read news while on the go, no matter which device they're using. We want to keep the user interface simple and clean to minimize their distractions. And we want to have the same set of features on all platforms. In this example, it might make sense to use the cross-platform approach. Because the user interface is supposed to be simple, we are not going to do any complex calculations, so we don't need all of the performance power of the device. And we want to have a simple user interface that looks similar on all platforms, which is another pro for the cross-platform framework. We're going to be developing the UI only once. And if you're wondering who else might be thinking the same, there's two examples. It's Twitter and Bloomberg in this case. Both companies have decided to use cross-platform frameworks to develop their mobile apps. The next hypothetical app we're going to look at is a video chat application. So what do we need here? Roughly said, we need to capture video with the camera, of course, process or encode it, prepare that for network transfer, and then actually stream it to other participants in the chat. So we need all the processor power we can get, as we want the encoding and processing to go as fast as possible. We also want the app not to freeze under heavy load. We want everything to go smoothly, even if there are a lot of participants and video streams in the chat. If we are not mindful of the performance here, the user experience could deteriorate very quickly, and it could lead to frustration of our users and even them leaving our platform because of their degraded experience. At this point, I'm going to invite you all to use the reactions available in Google Meet and share your thoughts on which approach you think could be sensible here. As you can see on the slide, you can use the thumbs up for native approach and the clap for cross-platform approach. Everybody native, all right. Awesome. So yes, in my opinion as well, going from the guideline that we mentioned earlier, I would also say taking the native development approach would make sense in this case. We have less layers of code between our logics and the processor, and this can also help if we have to debug code later on that isn't working as it's supposed to. It will make maintenance simpler. And going native gives us all the speed available and easy access to the hardware we need, such as camera or dedicated video processing units. Moving on to the next example, we have a case where we want to convert a web shop into a mobile app. So let's see what the hypothetical requirements would be here. Okay, we know we don't need access to any specific hardware, and we also don't need blazing fast speed, we are not going to be calculating anything much except the value-added tax, maybe. What we do need, however, is to get to our customers as fast as possible and on all platforms. And we also want to have the same set of features available to all users, no matter whether they are using the website or our apps. Again, if you wish, you can share your thoughts using the reactions we mentioned before. So it's thumbs up for native and clap for cross-platform. Oh, thank you for all the claps. So yes, in this case, I would probably also suggest going cross-platform. Like we have seen, we don't need any access to any special hardware or any specific performance, so that is not a hard requirement. And we want to get to market quickly, and we want to have the same features on all the platforms. So again, this speaks towards cross-platform framework. And if you're thinking what would be a real-life example of this kind of app, Amazon would be the first one to come to my mind. And last but not least, I have another interesting example for you. This is an application that uses the phone's camera and machine learning capabilities to recognize and label objects in the room using augmented reality and machine learning. You can imagine an app that would help mechanics see parts of a car's engine overlaid on top of their screen so that they can work on the engine more easily. Let's go through the requirements again. Well, of course, we need access to camera, right? We need to capture the field of view of the user. We also need machine learning capabilities to recognize the objects coming from the camera feed. And on iOS, the processor used for this is called Neural Engine. And of course, we want the app to be fast when doing all this recognition and placing objects on the top of the camera feed. So you probably see the pattern by now, right? Having access to specific hardware and specific performance requirement all speak in favor of using native development. However, like I said previously, it's not between right or wrong. It's about what works best for you. IKEA, for example, uses augmented reality in their app to display furniture in your living room. And they have actually used a cross-platform game engine to do it. So as you can see, it's actually much more complicated to choose, and the line between which approach is better can sometimes get blurred. So yes, it's good to know your requirements and know the advantages and limitations of each approach so you can make an informed decision. And as you have seen, choosing between native and cross-platform is not always as simple as perhaps initially thought. I want to emphasize that all of the examples can be built using both approaches. And the choice of development stack is certainly not going to make or break your project. Certain factors, like developer availability, performance requirements, or use of specific device features, can certainly influence the decision you will make. And the important thing to know is that there are different trade-offs to both approaches. And using the guidelines we looked at today, you might be able to predict those challenges better and be prepared for them once they arise. With that said, I wish you all the best in your iOS app development journey, whether it's cross-platform or native. All right, we've made it to the end. If you have any questions, please go ahead and ask. We can have a discussion. And also feel free to message me on LinkedIn if you have any questions afterwards. And thanks for all the support. Thank you very much. Go
I'm
ahead,
just
Ellen.
going to ask a question that came in, and it is, what should I use if I want to develop an MVP or a prototype?
Okay, whatever you're most comfortable with. I'd say that. I mean, it depends on whether you're a developer or project owner, but yeah, whatever makes you most comfortable. For MVP, definitely. Just go with what you have.
I also have a question.
Sure.
So it's regarding the maintainability of the two approaches. So which is more difficult or time-consuming to maintain, like two native apps or one cross-platform app? And which kind of challenges happen in both of these?
Okay, I'm going to give a trademark consultant answer on this one. It depends. It depends on the project. It depends on which type of developers you have, things like that. So probably the more specific you will get, the more you will know the right answer. But yes, if you have super skilled iOS developers or native developers, sorry, and you have two native projects, so for iOS and Android, the maintenance is probably not going to be that bad. And also, it's the same for cross-platform. If you have super skilled cross-platform developers, they will also be able to maintain your project fairly easily. So it's probably, it comes down to the design choices when doing the coding as well. Because you can have great projects in both approaches, but you can also screw up really badly on both approaches.